Tuition Mobile, quality e-learning experience on the go.
Hello and welcome back to the class. The topic we'll be discussing this time around is titled Surd. Okay, surds are numbers left in square root form, or they could be in cube root form, but they actually have roots attached with them. They are therefore irrational numbers. Okay, the reason why we have them as surd is because they can only be written in decimal form. Okay, and when written in decimal form, they would go on forever non-stop, and then the next thing we have to do is just to cut them down by approximation. Alright, and so surd is a very good way of reducing clumsiness in writing numbers, and so we'll be discussing multiplication of surds. There are laws guiding surds, and then we'll be discussing those laws, how we can operate using our surd. Okay, so the rules we have so far are given as follows. Rule number 1, rules of surd. Okay, rule number 1, we have that two roots a and b can as well be given as separately as root a times root b. Rule number 2 states that if two roots are under division a over b, they can be written in separate form as root a over root b. Okay, and then rule number 3 states that if we have two roots in the form of b over root a, okay, we write in this way. We have to multiply out. We have b over root a, okay, and then we take the denominator to multiply both sides. Alright, okay, which eventually gives us b root a over a. That's when we do the computation, but this is what the law states. Right, number 4, law states that if you have in a surd form a root c, okay, plus minus b root c, it is equal to saying a plus minus b root c. Okay, and so rule number 5 states that if we have a surd in the form of a plus b root n, okay, so we'll have to multiply both sides with the denominator like we discussed earlier, and so we have c over a plus b root n times a plus b root n all over a plus b root n. Okay, and so these are all the rules we have in surd. These are all the rules we have in surd. We shall be making examples of each of the rules we stated. We shall be making examples. Alright, if we are given questions in this form, for example 1, you're told to, example, simplify the following expression, and you are given 1 plus root 3 times 2 minus root 8. Okay, so how do you open up these brackets? 1 plus root 3 times 2 minus root 8. Alright, the same method of expansion we used for factorization, and in our algebraic equations will apply same method here. 1 times 2 is 2, and then 1 times root 8 minus root 8, and then 3 times root 2 plus 2 root 3, and then root times root takes care of the square root, and this gives minus 3 times 8. Okay, so we have 2 minus root 8 plus 2 root 3 times 8 is 24. Okay, and so we can simplify this further to give root 3 times root 3, okay, giving us root 24 minus and this is 2 minus root 8 plus 2 root 3. Okay, square root of 24. Do we have square root of 24? No, we don't have a square root, a perfect root for 24. Alright, well, we could look at things that when we multiply them we can obtain 24 and they have square roots. Okay, one of such numbers is when we multiply by 2, we multiply 24 to 12 by 2, we have 24. Okay, and there are other roots too that when we multiply we will have 24. Alright, but then let's keep solving, and at this point we have 2 minus root 8. Can we reduce this root 8 further? Yes, root 8 can mean root 2 times 4 to give 8. Alright, plus 2 root 3, we can't do anything here. Okay, and then for this root 2, root 24 could mean root 4 times 5. Okay, and so this helps us to reduce this, just like we stated here. Okay, you can separate the roots in the first law of Surds, and then we have 2 minus root 2 root 4 plus 2 root 3 minus root 4 root 5. Alright, 2 minus root 2 and 2, so root 4 is equal to 2 plus 2 root 3. Okay, minus at this point we have 2 root 5. Okay, and so this gives us the outcome of this sort, because when we have gotten to this point we wouldn't have any other simplification to make. Alright, so we'll take another example. So as we take more examples, we'll find solutions and do illustrations of these rules as given. Supposing we are given a rational number, this rational number, and we are told to simplify it. We are given numbers like a 1 over root 2. Okay, and then we are given b 1 plus 2 over 1 minus root 2. Then let me give like 5 examples and then we will close the class. I just wish you will understand what we are doing here. Alright, and then maybe you're given c, you're given other roots as follows. Then you're given c to be equal to 5 plus root 6 all over root 3 minus root 2. Okay, and then let's take that we are given root 3 and 3 plus root 2. Okay, and e, assuming we are given root 12 over 12, sorry, root 12 over 1 to 1. Alright, so how do we simplify the above? Alright, we take the solutions as follows. Solution a, remember in a we are given 1 over root 2. Okay, and from our law number 3 states that when you are given b, a number, and a root as a denominator, all you have to do is to take the denominator and multiply both sides. Okay, for this part you have root 2 times root 2 all over root 2 because times 1. Okay, root 2 times root 2 gives you root 2. Okay, and then this is as good as saying 2 times 2. Alright, and then at this point we have root 2 over root 4. Okay, because 2 times 2 is 4, which is equal to root 2 over 2. Right, and for solution b, you are given 1 plus 2 over 1 minus root 2. Okay, all you need to do is just like the rule states there too. It states that when you are given 1 plus b, okay, look at rule number 5. Okay, rule number 5 we'll be using for solution B. Okay, and so rule number 5 states that we also multiply both by the denominator, but we will change the sign of the denominator. Just like there is a minus sign here, we'll put a plus sign, and then we'll have 1 plus root 2 over 1 plus root 2. Alright, and so we have 1 plus 2 times 1 plus root 2 all over 1 minus root 2 times 1 plus root 2. Alright, and so we'll carry out that multiplication. 1 times 1, I think it's better here. 1 plus root 2, 1 plus root 2, okay, all over 1 minus root 2 and 1 plus root 2. I think that's right. Fine. So we'll carry out the multiplication. 1 times 1 is 1, and plus 1 times root 2 is root 2. Alright, and then 2 times 1 is 2. 2 times root 2 is 2 root 2. Okay, 1 times 1 is 1. 1 times root 2 is root 2. Minus root 2 times 1 is minus root 2. And then root 2 times root 2 is root 2 times 2. Fine. Okay, so this gives us 1 plus 2. I'm collecting like terms, and then root 2 plus root 2 all over 1 root 2 minus root 2, they cancel out, and then I have 1 plus 2 times 2 is 4. Okay, so at this point I have 3 plus 3 root 2 all over 1 plus 2, which is equal to 3 plus 3 root 2 over 4. Right, so this gives us the multiplication, which you can write as 3 over 4 plus 3 root 2 over 4. Okay, they're both the same thing with the answer above. So we'll go for the third solution. 5 plus root 6 over, alright, so we have 5 plus root 6 for solution C. 5 plus root 6 over root 3 minus root 2. Alright, so all we have to do is to multiply by the denominator, changing the sign, and so have root 3 plus root 2 all over root 3 plus root 2. Okay, and so when we multiply, we have 5 plus root 6 times root 3 plus root 2 all over root 3 minus root 2 times root 3 plus root 2. And so the next line, we have 5 root 3. When you carry out your expansion of the bracket, and then you also have 5 root 2. Okay, and then we'll have root 3 6 times 3. Okay, and then we have plus root 6 times 2. Alright, and then on the denominator we have root 3 times 3. Okay, and then we have plus root 3 times 2. Alright, and then we'll have minus root 2 times 3, and then we have minus root 2 times 2. Okay, so at this point we can say 5 root 3 plus 5 root 2 plus 2 times 6 is 18 root 18. Okay, and plus root 12. Alright, okay, so this and this gives us root 9 plus root 6 minus root 6, and then minus root 4. Okay, so this is equal to 5 root 3 and plus 5 root 2. All right, plus root 18 we can write as root 9 times 2. I think that will go, and then root 12 we can write as root 4 times 3. Okay, so that at this point square root of 9 is 3, root 6 minus root 6 will go off, and then we'll have square root of 4 is 2. Okay, so on the next line we have 5 root 3 plus 5 root 2 plus root 9 root 2 plus root 4 root 3. Okay, alright, so we have 3 minus 2 to be equal to 1, which is equal to 5 root 3 plus 5 root 2. Okay, and then plus square root of 9 is 3 root 2. Okay, plus square root of 4 is 2 root 3 all over 1. So we collect like terms. We have 5 root 3 and we have 2 root 3, and so we pick them together. We have 5 root 3 plus 2 root 3. Okay, and then on the numerator we have 5 root 3 and we have 3 root 2 plus 5 root 2 plus 3 root 2. I think that's what we have. Yep, all over 1. Okay, the 1 doesn't really matter, so this will give us to be equal to 7 root 3 plus 3 plus 5 is 8 root 2. Okay, so that whole fraction has been divided and simplified into that. Alright, so let's go on and do D. We have root 3 plus root 2. Solution D, we'll have root 3 and then 3 plus root 2. Alright, so how do we go about doing this? How do we go about simplifying this? Okay, we can multiply into the brackets, so we can expand the bracket, so it becomes root 3 times 3 plus root 3 times root 2. Okay, so from here we have 3 root 3. Okay, and here we have plus root 2 and root 3. Alright, and so we can simplify this by saying that 3 root 3, because root 3 is common between the brackets, okay, is equal to 3 plus root 2. Alright, this necessarily doesn't need any much computation because it looks like a final outcome. Alright, that's by the way. We look for more challenging questions. We have square root of 12 over square root of 1 to 1. Let's try to simplify this and see what happens. Remember what the rule of square root states, that for solution E, we have all in square 12 over 121. Okay, and we are told that from the rule that if you have square root of A over B, it's as good as saying square root of A over root B. Okay, and so we will say root square root of 12 all over square root of 121. Fine. Okay, so 121, we can do something there. We have root 12 over 11, because square root of 121 is 11, but root 12 can be written as root 3 times 4. Okay, all over 11, and so this will be equal to 2 root 3 all over 11. Alright, these are the little logical questions we have for this section of our study. Catch you up in the next class. Good day.